Here we go. So, today we're going to learn how to be able to sketch 2D vectors on a coordinate plane, add and subtract 2D vectors, graphically calculate the resultant of two-dimensional vectors that lie on axis, and calculate the components of a two-dimensional vector. All right, so hopefully that pre-quiz went well. Here's one thing that I think I need to clarify. So when you do like 150 meters at 70 degrees west of north, to decipher this, if this isn't something that's obvious to you, here's how you decode this. Read it backwards. Okay, what do I mean by that? Start with north, go west. How far? 70 degrees. That makes sense? Read it backwards. North, go west from north by 70 degrees. Okay. All right. So let's. All right. So we're going to use these vector arrows to help us illustrate vectors graphically. So to find the resultant, let's take this scenario. Let's say you walk 500 meters south and then 1,300 meters west. What is your resultant or your total displacement of that trip? Okay. So we're going to put these vectors on a coordinate plane. You got 500 meters south, 1,300 meters west. Okay. So when we find the resultant of this, we're going to do what's called head to tail. Often I refer to it as cut and paste. So I'm going to take the purple arrow and I'm going to move it, cut and paste it so that the tail of the purple is now at the head of the green. Okay. Notice I did not change the direction that's pointing, nor did I change the length of the arrow. I'm just changing where that's located. Okay. So this is known as head to tail. Taking the tail, putting it at the head. Okay. And then my resultant, so I'm going to start at the origin and I'm going to draw towards the final head. Okay. This would be the resultant. This is how far you were away from where you started. Okay. How would you find the length of that blue side? Okay, break out your calculators. And you got 1,392 meters. Okay, so good with that. So so I'm asking for a displacement measurement. So that's the magnitude. That's how far you ended up away from your starting point. But I also need a direction because it's a vector. So could I say 1,392 meters southwest? Well, what about this being southwest? right? And like, ugh. So I need something more specific. What do you think I need to do? I need to find my angle in degrees. Okay. So technically, because we found the length of this side, I could use any trig function. However, here's my recommendation. You might have messed this up, hit a wrong button, something. I would highly recommend, if you can, use values that were given to you originally in the problem. So try to figure out the angle with the 1300 and the 500. Tell your neighbor what trig function you're going to use and go ahead and figure that out. Okay. So hopefully you said tangent, opposite over adjacent. And you found that to be 21 degrees. Good with that? Thumbs up if you got 21 on your calculator. Okay. Now, if I told you to go 1,392 meters at 21 degrees, hopefully all of you would be like, all right. And then you'd start walking that way. Right? Because you start at 0 degrees at the x-axis. So like, oh, wait. No, let's see. Shoot. So you could say, hey, go at 21 degrees below the negative x-axis. Okay. You could say go at 21 degrees south of west. You could get mathy and say go at 180 plus 21, so 201 degrees. All of those are valid. Okay. Is that question? Yep, 201 degrees. Because the convention is we start here at 0. Okay, Killian.
Could I say, like, because 90 minus 21 is 69. Could I say 69 degrees west of south?
You could. Okay. So any of those are valid, but you also need to be okay with, if you're given any of these, you know what this is talking about. Does that make sense? Okay. So follow-up question, how did I know to do the purple? How did I know how to cut and paste the purple? I mean, here, I move the purple over. What happens if I move the green? Okay. If I move the green, I get the same resultant. But my tangent now then becomes 1300 over 500. Does that make sense? You're like, oh, how is that the same? Well, you get 69 degrees. And so you could say, well, at 69 degrees to the left, have the negative y-axis. You could say at 69 degrees west of south. Good with that? Questions there? Okay, so all of that's valid. So it does not matter which one you cut and paste. Okay, here is a very popular pitfall. You're able to get the right resultant, like the magnitude of it, you're going to get 1,392. But good luck with the direction. Does that make sense? Okay. What you failed to do was you forgot to do the head to tail. You needed to cut and paste, and this is your quality control. Your resultant will always start at the origin and draw away from it. Okay. Here you did not start at the origin. Good? Okay. Give this one a shot. Tell your neighbor. Correct answer is? Correct answer is D, dangerous dinosaurs. Okay. You gotta cut and paste. You've got to start at the origin and draw away from. Okay, got to start at the origin and draw away. Good. Heads up. You're subtracting. Thumbs up when you have a guess. have a conversation and tell them why you think what you think.
You're going down while trying to go up. Well, yeah, tail thing goes north. You said B. When
Correct answer is? Good job. Dangerous dinosaurs. Which one are we applying the negative to? T. So I'm flipping the green. Head to tail. The resultant. Good? Okay. Thumbs up when you have a guess. Compare answers.
actually it wasn't big. I got to see you didn't hear that. It's really B combined. It makes sense. I watched it on 2 times speed. I didn't do it.
I got a 2 out of 5. I watching the video. So
Do we get graded on the actual score, or do we get graded on just like
If you get 3 out of 3 or 2 out of 3, it's 100%. Okay. Correct answer is? All right. I'm going to make B green. Okay. I'm going to cut and paste one of those. Okay. And then I start at the origin and draw away. C. Okay. Let's say I cut and pasted the A vector. Getting it up the same spot. Good? Okay. All right. A minus B. Thumbs up when you have a guess. Converse. Tell them how you got there.
So you gotta go the other way. Yeah, A that's down. Yeah. Switch down, and that means that the hypotenuse goes straight on. So that means
it goes from this to this.
yeah, A plus B would go that way. So you don't need the A, you need it down. The arrow
So
right there
like
would
whenever
be
you see
down
negative
there.
B, I mean that's what we say.
Yeah, negative B.
What is negative? That makes sense.
All right, what do you say? Good job. A. Okay, which one are we flipping? B. So here's B. We're going to make B green. I'm making it negative. So now I'm just finding the resultant of those. Start at the origin, draw away. Solid? Okay. Use your desk. Tell your neighbor.
I think it's B. Why is it B? Because you're able to swim, because the current's not pushing against you forward, it's pushing you to the side. That means you're going this way. So like, let's like, hold on. 9 plus 12, that's 21. Square root of 21, that doesn't work. So, A squared plus B squared.
What's 4 squared?
25, so that'd be 5. Oh, let's see. 3, 4, 5, try squares. 3, 4, 5, try.
I mean, it's springs, like it's not like
16, 4.
What do you say?
C.
She is correct. Okay, so let the river's going 4 meters per second. That way, let's say. If you made it go the other way, it's fine. You're swimming 3 meters per second this way. The combination of these would be the resultant. 3, 4, 5 triangle. Okay. Here's a quick demonstration. This is a swimmer. We're going to put them in a swimming pool or a pond or a lake, still water. This is how fast they swim in still water. Good with that? Now, we're going to put this, a swimmer in a river. Okay. And I'm going to be the current. We're first going to go downstream, so with the current. And so you're going to see, you're on the bank watching the swimmer. Does that make sense? As they're swimming downstream, they went a whole lot faster. But when they're swimming upstream, good with that? Okay. So this question is talking about across the river. So while the swimmer is in the river, good with that? It's going like that. Okay. Going like that. Here is a gaming hack. So if you go forward, like you're moving on the screen, your character is moving, has a certain top speed. Okay. Some games have strafe, is that the right term? Or you can go sideways. If you can do, if the game allows you to go forward and strafe simultaneously, you actually go faster than you can just going straight. Like your top speed can just be, you can go 5 meters a second instead of 3. Or whatever your numbers are. Does that make sense? Physics, crazy. Okay. All right, components. This is how much of a vector is going purely in the x direction and how much of the vector is going purely in the y direction. So we're going to look at taking a little stroll of 120 meters at 50 degrees, 30 degrees east of south. What?
That's out there.
Yep. All right. So 30 degrees east of south. Quick little start with south and go east 30 degrees. Good? Okay. In my journey, did I move at all in the southward direction? Was I moving sort of south? Yes. Was all of my motion southward? No. But some of it was. How much of it was? Well, actually, I'm going to make this a little bit shorter so you don't get derailed by something. I'm going that far south. You're all right with that? How would I solve for the blue side? Tell your neighbor. Okay, so I'm looking for the adjacent side. I've got the hypotenuse. So I'm going to use cosine of 30 equals delta y over 120. Does that make sense why I'm using delta y? Okay, so change in y position. Okay, so I find that to be 104 meters. Thumbs up when you concur with that. 104. Now, I could say 104 meters south, but what I'm going to coach you to do is say negative 104 meters because it's going in the negative y direction. Good at that? Bless you. All right. I'm going to have the same conversation with the x direction. Was some of my motion, sorry, did I walk at all eastward? Yes. Was all of my motion eastward? No. Some of it was, though. How much? About that much. You okay with that? Turns out that green side, that's the same length as that. So, how, using the 120 and the 30 degrees, I'm going to find delta x. Tell your neighbor which trig function you're going to use. So I'm going to use what? Sine of 30 equals delta x over 120. Sine of 30 is 1/2. Okay. And is that going in the positive or negative x direction? It's going in the positive x direction. Okay. Good with that? So while I walked 120 meters at 30 degrees east of south, I walked 60 meters in the positive x direction or eastward, and I walked 104 meters southward or in the negative y direction. Okay, those would be my components. Now, have you ever heard of the word components prior to this class? Okay, usually it means like parts or pieces that like add up just like of the whole, like, right? Okay, check this out. Find the resultant of the blue and the green vectors. Find the resultant of the blue and the green vectors. You get what? You get the red vector. You see how that's working? The components are pieces of the whole. That's why we call them components. Okay? Good with that? Now, for this next question, I don't want you to calculate it. I just want to use process of elimination, and assuming that that diagram is drawn to scale, see if you can figure out what the correct answer is. But don't tell anybody yet. Thumbs up when you have a guess. Have a conversation. Tell them why you think so.
Because if you look, you see that the curve is very steep, which means the y is the greater number. But you can also see that it's negative x, so it has to be a negative number. But it's a positive.
It's a negative.
Yeah, negative x positive y. So the y is much greater. It's greater than the x value, so it has to be b. Because the x is smaller than the y. Science, math, whatever.
Correct answer is?
B.
Correct answer is B. Good job. So you know that your y component is greater than your x. And the y component is positive, or the x component is negative. Good with that? Okay. You got a worksheet due tomorrow.